Welcome to final BSc Statistics students in paper 6 in unit 2. Today we discuss lesson 2. Lesson 2 is construction of R chart. Construction of R chart. Earlier we have discussed construction of X bar chart. The first 3 points which are same in the construction of R chart as well. That is, first step measurement is as usual, same. Second step selection of samples or subgroups, which is also same. Now third step is calculation of X bar, R and S for each subgroup or the sample. Here no need to calculate X bar and S values. If you calculate all the corresponding values regarding R, which are enough. So therefore I am starting step number 3. That is third step. Step 3. What is step 3? Calculation. Calculation of R. Calculation of R for each sample. For which recollect once again Xij is the measurement of jth unit. How many units are there? N units, total N units in the ith sample. Ith sample. If you consider there are k samples, I is equal to 1 to and so on k. 1 to and so on k. For example, there are k samples, which means you have to calculate R1, R2 and so on Rk, in which I am writing the formula Ri, general one, for ith sample range. How to calculate it? Maximum of Xij with respect to j minus minimum of Xij with respect to j. That is, we consider in the sample Xi1, Xi2, Xin, we consider maximum value, among which we consider also minimum value. If you subtract it, you will get the range Ri. This is the usual formula, well known formula to us. Right? After calculating Ri, we have to calculate, furthermore we have to calculate R bar. What is R bar? Average of all these ranges, R1, R2, Rk. That is average of all the ranges, sample ranges, R1, R2, Rk. That is R bar. R bar is calculated by how many samples are there? K. Therefore 1 by k summation I is equal to 1 to k Ri. This is the simple formula of R bar. We calculate in this contest. R bar is equal to 1 by k summation I is equal to 1 to k Ri. That is R1 plus R2 plus and so on plus Rk divided by k, because of the k samples. Right? This is the calculation part. Third part, calculation of R. Now you go to the fourth point. Now you go to the fourth point. What is the fourth point? Fourth point is setting of control limits. Setting of control limits. Control limits for R chart. So before starting the construction, that is setting of control limits, I will tell you two particular values from the distribution of R. From the distribution of R, we know two values. Expectation of R is equal to d2 sigma and standard deviation, that is standard error of R, is equal to d3 sigma. These are the two known values from the distribution of R chart. From the distribution of R chart. Therefore, from this, the first equation, I consider expectation of R is mean of R, that is R bar is equal to d2 sigma, which implies sigma is calculated by R bar by d2. Why this value I have calculated? Because of whenever sigma is not known, then we have to estimate with R bar by d2. That is simply sigma cron is equal to R bar by d2. Why cron? Whenever sigma is going to be estimated, we use sigma cron with the help of R bar by d2. So this is the formula. Remember this formula. And also remember standard error of R is equal to d3 sigma. With these values, we start the calculation of control limits. We set the control limits. First of all, I write the formula of control limits. Control limits means usually only we study upper control and lower control limits, UCL and LCL. That's what I explained many number of times. Control limits is nothing but UCL and LCL. CL is another indication of central line. CL is another value of another line which is central line, which indicates standards of the process. Okay. Now we start to consider any kind of chart. The control limits are calculated by the usual formula of expectation of t plus or minus 3 into standard error of t. That's what we have to calculate, in which t is equal to, now we are calculating control limits for R chart. Therefore, t is equal to R. Therefore, t is equal to R. Expectation of t plus or minus 3 into standard error of t, in which we consider t is equal to R because we are constructing control limits for R chart. That is the variable R, the statistical measure, the statistic R, right? So these are the control limits, which means you have to calculate expectation of R plus or minus 3 into standard error of R. That's what we have to calculate. Expectation of R plus or minus 3 into standard error of R. Remember this formula. Now we start the control limits. We start the control limits in two cases. Case 1. What is case 1? Standards are known. If standards are known, which means known meant by standards are known means here I specify, that is if sigma is known. Why I have specified only one parameter, mu, and why not mu and sigma? Because there is no concept involved here, mu. The concept of mu was not involved, only sigma is involved. So therefore, I have considered only sigma. Therefore, I have considered only sigma. If sigma is a known value, then what are the control limits of R chart? You consider the control limits of R chart. Just now I have considered expectation of R plus or minus 3 into standard error of R. The control limits of R chart are this. If sigma is known, therefore use the distribution directly and write the values. d2 sigma, expectation of R is d2 sigma plus or minus 3 into standard error of R is d3 sigma, from which we can write it is d2 plus 3 into d3 plus or minus 3 into d3 sigma. So these are the control limits, from which you have to write two control limits. One, UCL of R. I indicate R. This is UCL for R chart. So which is, you can easily understand, d2 plus 3 into d3 sigma. which we can write as small capital D2 sigma, where capital D2 is nothing but D2 plus 3 into D3. Hope you understand. This is the constant. This constant capital D2 can be obtained from statistical tables for different values of n. For different values of n, we can compute, we can simply take the values of D2 for different values of n from the statistical tables, right? Similarly, LCL of R, lower control limit, it is going to be calculated by D2 minus T3D3 multiplied by sigma. We usually note it down as D1 sigma, capital D1 sigma, where capital D1 is D2 minus 3D3. Hope you understand. Similarly, now you consider CL of R. CL of R is equivalent to be, it is expectation of R. It is D2 sigma. If sigma is known, this is CL of R is D2 sigma. UCL of R is capital D2 sigma. LCL of R is capital D1 sigma. CL of R is D2 sigma. I again stress the point. Control limits are only these two. UCL of R, LCL of R. This is a central line. Fine. 3 sigma control limits are these two only. UCL and LCL. This is case 1. Now we study case 2. Case 2. What is case 2? Case 2 is if standards are not known. The case standards are not known, that is sigma is not known. I again repeat, we do not consider mu because mu is not here in the entire calculation of R in any formula of even in the estimation. Therefore, we consider only sigma. So if we consider sigma is not known, then what we have to do? In which manner do we have to calculate this? We go directly in the formula. Therefore, 3 sigma control limits. In this case, control limits of R chart are calculated by considering 3 sigma control limits are calculated by expectation of R plus or minus 3 into standard error of R. This is what exactly usual notation we calculate this. So now you have to consider in the 2 particular forms I calculate this so that you can easily understand. First you see expectation of R plus or minus 3 into standard error of R. Expectation of R, when sigma is not known, it is going to be estimated by R bar by D2. It is estimated by R bar by D2. Therefore, I am writing expectation of R is equal to R bar, not R bar by D2. Expectation of R, the value is also can be written as R bar. I will explain another form as well. First of all, you carefully listen this. Expectation of R is R bar plus or minus 3 into standard error of R. It is not a known value for us, D3 sigma. So R bar plus or minus 3 into D3 multiplied by sigma is not known. It is to be estimated. Hence it is sigma cron. Now you write down the value of sigma cron, that is estimated value of sigma. It is R bar by D2. Hope you now understand the pattern I am writing. This is D3 sigma, this is R bar. Expectation of R is R bar. And then sigma is replaced by, because it is not known, it is a not known value. So therefore I am writing as sigma cron and I replaced it with R bar by D2. Now you take a common as R bar. The remaining values are 1 plus or minus 3 into D3 by D2. Hope you understand. Multiplied by R bar. Okay. D3 by D2. 1 plus or minus 3 into D3 by D2 into R bar. This is the, these are the control limits. control limits for R chart when sigma is not known, when standards are not given, not known. Now I derive this particular formula in another fashion. You see here, you observe here, expectation of R plus or minus 3 into standard error of R. If any of you confused, you follow this. Expectation of R, as usual, we know it is d2 sigma plus or minus 3 into standard error of R is d3 sigma. Okay, nothing confused. d2 sigma is R bar. R, let it be d2 multiplied by R bar by d2. Sigma is replaced by sigma cron. d2 into sigma cron plus 3 into d3 into sigma cron plus or minus 3 into d3 multiplied by sigma cron is again R bar by d2. We can cancel out d2 and the remaining values are R bar plus or minus 3 into d3 multiplied by R bar by d2. Hence we can write as it is. Now we can take a common as R bar and 1 plus or minus 3 into d3 divided by d2 multiplied by R bar. Hope you understand. Now we got the same value. 1 plus or minus 3 into d3 by d2 into R bar. So this is what exactly in the both cases what I have derived, we got the same value. So these are the control limits. Upper control limit, one gives plus gives upper control limit, minus gives lower control limit. So therefore now we write UCL and LCL and CL, the control limits. UCL of R, I am indicating UCL of R. The value here 1 plus 3 into d3 divided by d2 multiplied by R bar, I am writing as d4 R bar. I write again in the, hope you understand, where d4 value is this. What is d4 value? d4 is equal to 1 plus 3 into d3 divided by d2. Whereas if you consider further, which means now you observe this, and LCL of R is going to be calculated by 1 minus 3 into d3 divided by d2 multiplied by R bar. Hence I write as d3 R bar, where d3 is going to be calculated by 1 minus 3 into d3 by d2. These d3, d4 values we can obtain from the statistical tables again. I repeat, d3 and d4 we can obtain from the statistical tables, right? So what is CL? CL of R, central line, which is nothing but expectation of R. It is simply R bar. You have to remember in this context, expectation of R is equal to R bar. If you remember this, we can do it very easily. Or otherwise you have to replace it, d2 multiplied with sigma cron is replaced by R bar by, is to be replaced by R bar by d2, and then by cancelling we will get R bar. You see, you observe here. This is the procedure. Otherwise, if you remember clearly, expectation of R is equal to R bar, no problem. Directly we can substitute the value. So therefore UCL of R is equal to d4 R bar. You remember the formula, you by heart the formula. UCL of R is equal to d4 R bar, LCL of R is equal to d3 R bar, CL of R is equal to R bar. Okay, again I explained in both the cases, these are the control limits. In both the cases I explained the control limits. UCL of R, in the case 1 standards are known. Then UCL of R is equal to d2 sigma. This is the formula, d2 sigma. LCL of R is equal to d1 sigma. This is the formula. And CL of R is equal to small d2 sigma. These two are capital letters, d1, d2, capital D1, capital D2. This is small letter, d2 sigma. This is the case when standards are known, sigma is known. When a case, if standards are not given, in this case, UCL of R is equal to d4 R bar, LCL of R is equal to d3 R bar, CL of R is equal to R bar. In this case, CL of R is equal to R bar. These are the control limits. Of course, I repeat again and again. Control limits means UCL and LCL. Central line is a separate one. It indicates standards of the process. CL of R. Remaining all construction and everything is same. So, but I'll tell you again. In the construction of R chart, what we have to consider? We consider, in the construction of R, we consider on x-axis we consider different sample numbers. Sample number. Sample number. On y-axis, what you have to consider? Measure. Quality scale. A measure, which is sample range. Sample range. That is the values of Ri. We have to consider here. So these are the sample numbers 1, 2, 3, 4, 5, 6, 7, 8 and so on. And as usual, let it be whatever the computed value we obtain as the CL, we have to draw as bold horizontal line, that is CL of R. Some particular value, let it be some 10. Like and similarly, we have to draw two more lines. One LCL of R, two UCL of R, which also some kind of values. Okay, and with the help of this, we have to draw one after another the ranges corresponding to first sample number. The range is something here, somewhere here. For example, R2 corresponding to second sample, somewhere here. R3 corresponding to somewhere here. For R4, so somewhere here, etc. Now what you have to do is we have to join those points respectively, and then you will get a constructed control chart of R. Okay, this is one such manner we construct R chart. It is named as R chart. This is the another point, construction. Next point, construction. That is fifth point, construction of control chart. Construction of R chart. What is construction of R chart? In the construction of R chart, what we have to do? We consider sample number on x-axis and sample ranges on Ri on y-axis, and then we calculate whatsoever computed value CL, LCL and UCL we have to draw here. CL is to be drawn as, at a respective value, it is to be drawn as bold horizontal line, and LCL and UCL are to be plotted at respective values as dotted horizontal lines. Dotted horizontal lines. Take a scale and then do it. And then at the end, what we have to do? We have to take each and every particular sample range for all respective sample points. So for first sample, the range R1, it is to be somewhere the point will be there, and you have to plot the point. For corresponding to sample 2, R2 to be considered, and it is to be plotted in the respective value. Similarly, R3, R4, R5, R6, how many number of samples we have to draw range. We have to calculate range, and we have to draw a particular point on the graph. Now we have to see whether the process is under statistical equality control. When do you say? If all the sample points, that is this entire picture, is within the UCL and LCL, then that process is said to be under statistical quality control, which means there is the process is under statistically quality control according to R chart. So therefore, if any particular point outside the UCL and LCL, that is beyond the UCL and LCL, outside the control limits, for example here, instead of this, if this particular value has been plotted, then we don't have this one, then we have to do in this fashion, and so that now it becomes this particular chart is out of statistical quality control according to the R chart. The process is said to be out of statistically quality control since one of the point fall below LCL. So this is the construction of R chart and the conclusions. The conclusion is nothing but just now I have explained through this particular chart. If all the sample points, that is sample ranges, if all the sample ranges fall between LCL and UCL, upper and lower control limits, then the process is said to be under statistically quality control. If any one of the sample point fall above UCL or below LCL, that is beyond the control limits, then the process is said to be process is said to be out of statistical quality control, not under statistical quality control. One more conclusion, one more small point in the conclusion, in the construction of the control chart. If LCL of R is negative, then we have to consider as 0. We have to consider as 0. LCL should not be negative for the range chart. Keeping this point in mind, and we have to whenever in the part of construction, whenever we get LCL of R is negative, then we have to convert it as 0. If it is negative, LCL, only I am talking about LCL. If LCL is negative, then you have to consider as 0. So the remaining all interpretations are same. What are the sixth point? Interpretation of control chart, R chart. What is interpretation of R chart? It is nothing but whenever if all the sample points fall between the control limits UCL and LCL, then the process is said to be under statistical quality control. If any one of the point fall outside the control limits, that is above UCL or below LCL, then process is said to be out of statistical quality control. Whatever the assignable causes are present, we have to indicate those assignable causes of variation. Usually, according to R chart, assignable causes of variation are neglecting the part of the operator. Hope you understand. Thank you very much.